Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 55, we continue building with Arduino, and this is part 2 of the previous lecture. So the different concepts that we will cover will be on IoT prototyping using Arduino, Arduino IDE installation, Arduino IDE itself, we will talk about it, and then we will talk about the Arduino libraries. Then we will show you what is a breadboard and how to use it, and then we will do our first Arduino circuit, which is the blink LED circuit. That means we will show a LED to be just blinking, and then we will do a little bit complicated more circuit, which is a traffic light circuit, right? And in the next module we will give you a lot of a demo of the projects, but these two projects will actually help you to understand how this is done, and you will see that it is not that difficult. So of course we have already learned how to write a bit of code in Arduino in the previous lecture, but here we will first install the Arduino IDE. That programming environment has to be first downloaded and set up, and we will build our first physical circuit using and that we can say it would be our first IoT prototyping project. So Arduino IDE is the integrated development environment, and it's the graphical user interface which connects the user with the microcontroller hardware. So that means we have our circuit, we have our PCBs, or we have a microcontroller setup, Arduino Uno or those kind of boards, and what the microcontroller, that particular board will do, how it will control the sensors, everything has to be informed by the user. And this is the graphical user interface allows us to write the programs to do that. So this code is overall this IDE is based on C++ language, and it has got many built-in libraries for different sensors and different other IoT purposes, different purposes that is required to build IoT products and all. So this actually helps us to write compact codes, and these compact codes could be then compiled, and once it is compiled we can upload it to the microcontroller memory, and then once it is there it will run on its own. As you know that we have already talked about the void function and the setup function and the void function inside that code, and the void part run and that loop part void within that, then there is setup, and then there is the loop part, right? And the loop part continuously runs. So this Arduino IDE supports cross-platform development between Windows, Linux, Mac, and so on. And then the programs that we will write is known as Arduino Sketch, and then we can compile those particular programs, and finally we will upload the code to microcontroller, whichever microcontroller we are using, and then finally we can also monitor what is being executed in the microcontroller if via the serial monitor. That means if I connect our laptop or our computer with that, but using the USB, we can also see what is going on. It would give us back a feedback that whatever is running in the particular microcontroller, and that we can see in our screen as well. So that's the serial communication will happen, and we can see that in our computer monitor. And so you can go to the official website. This is www.arduino.cc, and you can download the Arduino IDE. This is the latest version, and I think 3 or 4 is the latest version. So this you can download from here. You run the installer, follow the setup instructions, and then install the USB drivers if those are required. And if you don't have the USB drivers, and these drivers will support the running of the board. So we will talk about that. That means as soon as you connect the board, it requires some drivers to be to run create that interface between your computer and that particular board, right? So without those drivers it will not work, and that has to be there. And then we launch the Arduino IDE after installation, and then we can start writing codes and then pushing codes to the microcontroller. So this is the first, after you go to the website, this is what you will see, and you can click on download, and you will more or less it will most likely it will point to the right operating system that you have in your computer, and then you can download it. And once you download it, then you will come to the license agreement. You have to agree, and then once you agree, then you keep on downloading it, and then eventually the download will finish, and you can run the Arduino IDE, and you can click on finish. Now, as I was telling you, that means one important thing is, of course, the USB driver setup for the system and the board communication. That means so that your system and the board can communicate, that has to happen. And this driver allows the operating system to recognize Arduino as a serial communication device. That means it will communicate via, in the serial mode and through certain communication ports. I mean, these are, communication channels that are there, and we have to select which port rather, right? So that is it's a part of the operating system. We can, we can select that, okay, this particular USB, this particular system that we are connecting would be communicating via port number 3, 4, something like that. So, so usually this happens automatically. That means when you as soon as connect this particular Arduino board using your USB cable with your laptop or computer, it will automatically detect. But if it is not, then you have to go and you have to select, and and find, you get to go to system preferences and see the system settings, see the list of ports, and check what port is assigned to Arduino. If it is not, then we have to further tweak with it. So this is the Arduino IDE. You can see over here there is void loop, and then there is void setup. So these are the these are the two major functions that are there. So void setup, as we have discussed earlier, is to write down the different instructions, that which pin will be input, which would be output, and basically for configuration. And the void loop is the instruction that what will run after this. And in addition to void setup and void loop, we can also have a set of functions and all those things which we can also declare beyond this as well. So this is the Arduino IDE. So you can see the menu bar at the top, and you can go and open up each of the menu items and see what is there. So under sketch is basically a program in Arduino, and you can verify a particular code. You can upload the code to the board, and all these things you can do. And similarly, you can go to tools, and you can see the different tools that are there. There you can see serial monitor or serial plotter. That means when you click on serial monitor, you will see the a window will open over the IDE, and you can see what is happening in the microcontroller. Whatever code you have saying that it should be, when we write code, we also give instructions that if something is successful, it will also, we can print it out. So this is a confirmation that you can make sure that is happening, and we can check that confirmation in this this serial monitor. And serial plotter is, of course, it can plot it as well. And then over here you can see the board and the port, and when you click on this, you would be able to see that, okay, which board is there, and you can select from that board whichever board you are using, or then to port, automatically it would get detected, or we can also do some amount of selection. So serial monitor is for data communication. Then because each Arduino board has got different microcontroller, that means we have already discussed that Arduino board can have different this 80 mega would be a microcontroller, or we can also have some other microcontrollers as well within the same Arduino board, and that actually that requires the compiler to compile the program in a different way. That means the compilation is converting the program to machine language, right? So that because the microcontroller is different, the instruction set should be different. So the compiler has to be changed. So that is why we have to select the right board over here. It's not generic. It is for specific board. We have to select specific first, and then accordingly the compiler will compile. And then similarly port can also be selected. So usually when you click on port, then like when you click on board, you will got to see this like Arduino Genuine Uno. So that means it is determined, it is, we can select that particular board from this list. And at the same point of time, if I click on port, you probably, this is selected, COM6 is selected, because in my laptop it is, coming as COM6, right? So that can be different in different setups. So it could be COM3, COM4, these are more common you will see, but sometimes it is also, like over here you can get COM6 as well. So the port is the communication channel, and so from USB it happens via the USB to serial chip, that is 80 mega 16U2. So which this we have discussed earlier when we have elaborated on the the entire Arduino Uno board, and this enables the data transfer, and using that we can this communication can happen, and this port. Sometimes you may get this command like port not visible. That means over here you may not see any of the ports, right? So that means the driver is not properly installed, or there may be a cable issue. That means so you can always check if the cable is properly connected, or you can go to control panel, open the device manager, look under ports, COMs and LPT. There should be an open port named Arduino Uno COM XX, COM6, COM3 something. If not, look in other devices for unknown devices, and then you can click on that particular port and choose that, or if it is unknown device, then you can update the driver software, and then probably it would be getting detected. So what it does is this integrated development environment, or this Arduino IDE, it compiles the code and uploads it to the Arduino's flash memory through a bootloader. So that means there is an inbuilt bootloader in the Arduino board, so we don't have to have create it separately, right? So this automatically does that, and it gets uploaded in the microcontroller, and this so that means this is you can understand that when you do that, this will become your embedded program. That means this is your first embedded program, right? And then sensors, actuators and IoT hardwares can actually talk to each other, and this becomes a sort of edge device. So that means you can build your edge device as well. That means you can write codes for it, and then you can start building your own IoT systems. So of course you have to learn a lot of many things than this, but first we should start to see about which libraries are already built in, so that we can use those libraries and the functions that are there, and we can choose those particular functions and incorporate that in our code, and we can be able to make the development time much shorter. So the Arduino IDE is extended through various libraries. Libraries are pre-written collection of functions and code that allow you easy interface with sensors, actuators, communication modules, displays and network systems, and we don't need to then write low level code, so we can just call the ready-made functions and we can utilize them directly. So this allows reusable and tested function, thus reducing development time, same as any other libraries, and enables communication protocols like Wi-Fi, MQTT, GSM. So this I2C, SPI, all these functions are written. We just need to pick and choose, and then it supports modular and scalable embedded programming as well. But the problem is the memory in Arduino is very small, depending on which microprocessor is being utilized. Like 80 mega is very little memory. So if you include a lot of these libraries and all, obviously the size of the program will be much larger. So we have to also make sure that we don't unnecessarily add some libraries, right? So only the ones which are required should be added. So first we have the EEPROM library. This enables reading and writing data to the permanent non-volatile memory of the Arduino board, and this is used for storing configuration parameters and sensor calibration values and so on. And typical functions you will see is like EEPROM.read, where the address is given, EEPROM.write, address and value is given. That means at where I want to store it and what value that is given, and then EEPROM.update, address and value is also given. Then there is the Ethernet library. This enables network connectivity both for local network and internet, and for that of course we have to have a Arduino Ethernet shield. That means you have to in some boards it's an inbuilt function, like the board that we would be using. It's Wi-Fi is a inbuilt function within that board, but in some boards you have to add a separate PCB, small PCB, which is also known as this Arduino Ethernet shield, anything like Bluetooth shield, right? So we use the term shield, and this is a separate circuit which has to be added. When you do that, then this Arduino can also communicate via this, also connect to the network. So this Arduino Ethernet shield or Ethernet compatible boards could be also widely used in IoT data transmission and web-based monitoring systems. Typical functions being Ethernet.begin, where we have to give the IP address and the machine ID, and the Ethernet.client.connect, Ethernet client.print, and so on. Then there is a GSM library where we can actually connect with the, using a GSM GPRS based communication module, and for that again we have to have a GSM shield for IoT, like Bluetooth shield, GSM shield, and so on. And this help us to do a lot of remote monitoring, like for example in a bicycle monitor system that we have been developing for a long time. We use GPRS chip and GSM chip so that we can do communications with the server. So that means in case we are also using a GPS chip as well. The GPS chip actually gets the data from the GPS signals and all, and it connects with the GPS satellites and gets the signal, and then it is transmitted over a GSM shield using a GSM shield to a server, right? And we follow MQTT protocol, TCP/IP, different protocols. So applications such as remote monitoring, SMS alert, and telemetry systems, all these things could be enabled by using this library. So some typical functions are GSM access.begin, GSM SMS.begin, SMS, so we can send SMSs, GSM SMS.print, and so on. Then there is the bridge library, which enables communication between the Linux processor and AVR microcontroller, and this actually helps to bridge between this two, and then functions are bridge.begin, bridge.put, bridge.get, and so on. Then more common functions that you will likely be adding is like I2C communication, wire library functions. And so this is used for communicating with I2C sensors and modules such as LCDs, MPU 6050 RTCs, and so on. And we start like wire.begin, wire.write, wire.read, and so on. Then SPI libraries for serial peripheral interface. We have discussed that in our previous lecture. It enables high-speed communication with peripherals such as SD cards, displays, and sensors. So where a lot of data needs to go back and forth. And this SPI begin, SPI transfer, SPI end, all this thing is part of that. Then servo library, which is used to run a servo. That servo is a motor, right? So that motor where we have control to rotate it at a certain angle. So this could be used to control servo motors in robotics and automation systems. So we can build our own vehicles, robots, and so on. So it's a motor which can move the arm, or it can move a particular appendage, or it can move a wheel. So typical functions are servo.attach, that which pin it should be, then servo.write, the angle, which angle it should move, servo.detach, that means it would be not running in that way. So then liquid crystal display library, this is used to interface with LCD displays, and in both embedded system and also in IoT dashboards. Typical functions are LCD.begin, LCD.print, LCD.set cursor, and so on. Then Wi-Fi library for IoT connectivity. It provides wireless communication for IoT cloud applications. So this is in ESP32. The Arduino boards could be like ESP32 boards or 80 mega boards. ESP32 is the processor. In that case, automatically we have got Wi-Fi. So Ethernet is just the LAN part, that is we are connecting with the net, and this Wi-Fi actually allows us to connect via this wireless protocol. So typical functions are Wi-Fi.begin, where I have to give the system ID, secure ID, and the password for the Wi-Fi network. Wi-Fi.status, Wi-Fi.client.connect. So all these are the different functions that we use. And then we can also have several external sensor libraries which we can also include, which is not part of Arduino IDE, but we can add them. So these are like the DHT library for temperature and humidity sensors, Adafruit sensor libraries. Several sensors could be from there. From Adafruit, there are several sensors under that. Then ultrasonic new ping library, MQTT publish pub sub client, this library, and IoT cloud communication. All this requires different kinds of devices or different kinds of sensors. So accordingly, we can add new libraries and we can build our code. So libraries allows abstraction and enable efficient interaction with hardware components, communication modules, and IoT platforms. Now we come to something called a breadboard. Now this is just a digital image, but this is the actual image. So this is like a plastic board, right? And you see so many holes in it, right? So a breadboard is a solderless electronic board used to build and test circuits temporarily. So usually if I want to connect, if there already we have learned there are several pins in the microcontroller. So every time I want to connect a pin to a sensor, and if I suppose have 5 sensors and then there are so many pins, 14 digital pins and analog pins and so on, then what we see is this digital pins and all these things, we require a lot of jumper wires to connect, or wires to connect between the pins and all, right? So jumper wires allows to plug in, it's a sort of a plug and play wire, right? So to avoid that means to have so many wires, we can have a breadboard. So if you see the breadboard, it contains internal metal strips below the plastic, of course, that electrically connect specific group of holes, right? So that means if you put two things in one, in a set of holes which are connected, automatically those gets connected. So this is basically a wire which is printed instead of the wire you are connecting outside, right? Since it is reusable connection, it is ideal for IoT prototyping and lab experiments. Now, by default, when you are making use of a breadboard and you want to follow protocol, then we will go like the colors that are given here. So for example, the red and the blue lines are long vertical columns on the sides used to distribute power supply. So you see that it is a connected power supply, right? That means it is broken in the middle, of course. So you see that this part is one line, this part is another line. Similarly, there is another set of holes, this part is one line and this part is another line, right? So what does red and blue means? Red is VCC, this is through which we get power supply, and then GND is the ground, that means through which the power is, it completes the circuit. So these two are very important, because in any circuit you want to have, you have to have a connection where the positive side is there and the negative side is there, and both needs to be connected, and then the circuit gets completed. So this allows us to do that, and within this rail we can have any number of things connected to that. So that means from Arduino board, where there is only one ground pin, we connect it with this one, with this particular one of the holes over here, and what happens is any other point you can connect other things which also requires a ground connection. Then automatically from multiple ground connection we can send it via only one connection to the Arduino board. So in addition, there are the center rows which are known as the terminal strips. These are used to place electronic components like resistors, LEDs, sensors and ICs and so on. So that means these are the pins. So if I can put a IC like this, we can put a resistor like this, we can put a LED like this. So depending on this is one line, this is one line. So these are two separate connections, right? Because these are in a horizontal way, these are in a vertical way. So this line and this line is not connected, but these 5 holes are connected, right? So we can create many combinations of circuit. It just allows us the flexibility to connect different items without the wires, right? So each horizontal row in the center section is internally connected in group of 5 holes, and the left and right center sections are separated by a gap, so that we can have, we can place certain things which requires that difference, and then we can place ICs and so on, and the vertical power rails run along the sides and are internally connected along the column to provide continuous VCC and ground supply. So this is our first, late IoT circuit or IoT prototype, you can say. What we are doing a very simple thing. We are building a circuit where we are just trying to, make a LED, glow, right? So what we require for that? We require the Arduino Uno board, we require the LED light emitting diode, and that is over here, you can see, and then we require a resistor, because we cannot directly connect the LED, because the LED requires lesser amount of current, and we need to protect it because the current provided by Arduino is 5 volt. So of course we don't require and more, the amount of the current is more. So we use a resistance to reduce that, so that our LED could be directly connected to limit the current and protect the LED. And then we have the breadboard, jumper wires, and a USB cable to connect it with my laptop or my computer. So this is the circuit diagram. This is a rough circuit diagram just to show you that this is the Arduino microcontroller. Even though we are saying Arduino, basically we are referring this is the microcontroller. and then D13, D11, D10, these are all the different pins that are there. So, and this side we have a ground. Actually it is not located like this, but for sake of explanation it is given like this, and we have analog inputs. Then there is the 3 volt or the 5 volt power connections, right? So what we are doing is over here we could have, if 5 volt is there, then normally what happens in this kind of smaller items, we don't require a power connection. The pin itself has the power connection, and that means if I connect directly with the pin, that particular LED light, automatically it will glow, right? So Arduino pin, what we are doing is this Arduino pin 13 over here, that is connected to the resistor, and then the resistor is connected to a lead anode. That means lead, the positive side, and the lead cathode, the negative side, is then connected to the ground. So this is which completes the whole circuit. So first job would be to insert the lead in the breadboard. So this is how we have done it. So this is, one is a long leg, one is a short leg, one is a cathode, and one is a anode, and then we connect the resistors in series. That means, see, this line is all connected. So when we are connecting this in series, that means one after another, right? And then from here it is going to this line, which is again connected, right? So because it is connected, now I can put a jumper wire over here, and then it goes and connects to the different digital pin of Arduino. And over here, from over this side, I can directly take it and connect to the this particular ground point, so that the circuit is connected, right? So this is basically directly we are doing, but from here we are first coming over to here, and then this is the ground, and then from here we are again first we are connecting this to this ground, and then we are connecting this to the ground pin. Now instead of this, I could have done the circuit in such a way so that I don't need to put another jumper wire. So it's very flexible. You can practically when we do it, we just make sure that the circuit is completed and we are using the right grooves in which to put the LED pins in, and so on. So but the rest you can understand. But if you want to do it like there are several components and all, you better follow that protocols of where to how to connect each one of this, then your circuit will be proper. So once we have done our connection, so I now write the Arduino code. So this is first I declare the LED as an integer, like which is the value of 13. Then within void setup, I am first doing the setup part, that is pin mode is LED, and then LED is basically 13. This is the which pin, and this is the output pin. That means we set the pin as output, and then the void loop function is there. Within that we will say digital write. Digital write actually will change the value of the pin, and again the which pin, this is 13, and we will make it high. So as soon as I make it high, the LED will turn on, and then I am giving a delay of 1000, means 1 second. That means it will be glowing for 1 second, and then we will also write digital write LED low, and then when it is LED low, automatically it will turn off, and then there is a delay of 1000, and then this keeps on going in a loop, right? So setup runs once, loop runs continuously, and delay of 1000 is basically 1 second. Now what we are seeing over here is, you can see the setup that we have done. So now we will look into how this will run. So over here we have connected the circuit, and you can see how now we will try to run it. So first, of course, when we run the program, it will compile the program. So I've just copied some part of the from below and put it at the top. So you can see the commands going on at the bottom, so which tells us that what is happening once the program is compiled, or this compiling of sketch that is going on over here. And once it happens, then it will start uploading it. And once it uploading means it is getting uploaded into the particular microcontroller. That means the code is being loaded into the controller. And once it gets uploaded, then we start, and we can we open the serial monitor, and you can see that what is happening over there, right? So we are saying digital write LED low, so automatically we can also see that that the LED is turned off or on. That also we can do, right? So then see over here, if you see what I have given over here in this code and what is written in this particular code on this side, there is a small difference. serial.printin is actually added over here, which is LED on. So that means it will print LED on. So serial.printin actually prints that whatever we want to print in a serial monitor. So and then we can open the serial monitor and we can look into that, right? So automatically when the microcontroller is running the code, automatically our LED is blinking. You can see this green LED is turning on and off, and we can say the same thing being printed over here, because we have accordingly we have written the code, right? That means this should print and then delay, and then it will again print. Of course, it will turn on the LED as well, and that we can see it happen. So this loops repeat continuously, and it will keep on blinking till we disconnect the circuit. Now the next program, or rather the next project I will say, or the next testing, we will do a little bit more complicated one, which is a traffic light, and we will introduce some more functions to it. So this is a description of that program, which says that Arduino, we are designing a sort of a traffic light system, and we are using again LEDs, buzzers, and a limit switch. Now what is a LED? We have already shown you earlier what is a limit switch. Limit switch is something, if you press something, then that press information could be conveyed to the microcontroller. So that means if it is pressed, microcontroller will know it is pressed, right? A buzzer is something like, we have also seen that earlier, that is it will make a sound, right? It's sort of a speaker. And LED we have also seen. Now we are using 3 LEDs over here, red LED, yellow LED, and green LED. And a red LED would be connected to pin 2, yellow LED would be connected to pin 3, and green LED would be connected to pin 5. And red indicates stop phase, yellow means the transition phase between green and red, and then green is the go phase. That means vehicles will start, right? So a buzzer connected is also connected to pin 9. It will provide sound alerts during some of the signal phases. That means we can say that when it turns green, it will start running the buzzer and so on. So a limit switch is connected to pin 7, which is also we would be writing a function for that, and which would be a emergency stop input. That means if I press the limit switch, the program will not run in the loop and it will stop. Now to make it happen, I have to always write code in the program saying that, well, if this is switched, if it pressed, then the program should stop. That means it has to be monitored continuously if this is being pressed or not, right? So that code I have to write. So I will show that. So Arduino initially initializes all the pins as inputs and outputs and begins the signal cycle. Program continuously checks the switch status, that is, is it stopped or is it on, and then it keeps it running, right? If the switch is pressed low signal, that means everything would be off, and then we have written a function which is all off for that, and immediately turns off all the LEDs and the buzzer and stops the system. But if it is not pressed, that is, it is in normal operation, then red LED will turn on and it will have a long buzzer beep. Why? Because we would increase the time of that buzzer beep, and this will indicate a stop. Then red LED then blinks several times, then green LED turns on, and multiple short buzzer beeps that will happen. That will say that, okay, you can start, and green LED and yellow LED turns on briefly in between for transition warning. The delay check function monitors, there is a function you will see in the code which is delay check, which monitors the switch even during delays for real-time interruption. That means if somebody presses, immediately that function will make sure that we can, that everything is stopped, right? So I have to write code below that function, that when within that code, if that particular that we have to say that, okay, we have to check if the switch is pressed, and then if it is pressed, it is turned off. So this overall thing will continuously repeat. So for this program, we again require the Arduino Uno, this particular prototype. We require the breadboards, we require 3 LEDs, red, yellow, green. We require 3 registers because we cannot directly connect the LED. We have to have a register because it will otherwise damage the LED, because the power required by the LED is very less. So one buzzer, we can use an active buzzer, and we are also using a limit switch or a push button switch, and then we would require several jumper wires. So first let us see the code. So first I will go to file, and we can, after writing the code, you can save it, or you can just earlier we were showing that, okay, this within Sketch we can actually type in this is we can compile the code, we can upload the code, all these things we can do. In tools, we can go and see that is here Arduino Uno R4 Wi-Fi is being used. So this is where we, our Arduino board is a little bit different, right? And so we are using this particular module over here, and then we are also looking into the different ports. So you see the port over here is COM19, which is for Arduino Uno R4, right? So this is the code then we have written. So first you see we will have the setup and the void later. So first we will add the different functions that we need. So instead of, because some of the coding would be repetitive, so we are made it in a function and we are calling the function later, same as Python programming. So over here you can see the initial, we are declaring all the different variables that we will require, and then bool stopped will return digital read switch pin is low. That means that the pin we will consider will be low, and then digital write, then the void all of function, that means everything will be turned off. That means all of the pins would be made into low, and then serial printed will say system stopped. And then delay check will actually check during delay even that if somebody is pressing that particular stop function. So if stopped, then everything would be off, right? So within delay part also it will run in this way. So it is not just delay, it is check within the delay, this will what is happening. So then we can roll through the other programs. You can see that then we will, this is the buzzer program that is over here. That means that using this function we can turn the buzzer on, and we can also within the function also we are doing delay checks. So within that also if somebody presses on the switch we have to stop it, right? So next we have the void beep. This is the buzzer function, and then we have the multi beep. This is a same buzzer function, but we are that means multiple beeps will happen. So if I call this function, a single beep will happen, and then in this function there will be multiple beeps, right? And then there is the then comes the actual void setup program, and within setup we are starting serial communication. 9600 actually is required for the serial monitor, and then the pin modes are first setup. Within setup, that is red pin is output, yellow pin is output, switch pin is input pull up, right? So that's the nature of the pin. And then for void loop, if stopped, all is off, otherwise return. So that means if it is pressed, then automatically it will return, right? That means it will stop everything and it will go back to the program. If it is then it will if it is not, then it will continue, and then it will first be red, serial printing red is on, digital write red pin high, digital write yellow pin low, green pin would be low, and beep would be 1 second. Delay check will also be 4000. So that means we would be also keep continuously checking the this if the this is pressed. So then for red, it would print 4. It would be doing 4 blinks. So accordingly, we will call the function, and then after that, you can see the red blinking function, the green function. That is, we are turning the pin for green on. And then the yellow, it is again on. When yellow is on, the green and the yellow other pins would be low. And then when yellow is on, green and red would be, so this is wrong, maybe red would be this thing. And then finally, once we have done that, we will upload the program, compile the program, and then we upload the program, right? So you can always make some code on your own, right? Now that you know how to write basic code on turning a LED on and off, and you can include delays, and you can create a sequence, and then you can also add that checks that okay, if that button is pressed, that function you can include, and you can call as per your wish. So this is where the entire program comes together, this is where we have actually done the connections, and we have set up the entire prototype. So Arduino ground is basically that breadboard blue line, So it is a common connection for LEDs, buzzers and switch. So that means all the the anodes will be connecting with this particular the ground through this particular breadboard blue line, like through one common line at the edge. Then red pin is connected to pin 2, Arduino D2, and then resistor is given, then the lead anode, the long lead, and the lead cathode, after that the short lead. This is a series in which the connection happens, and then it goes to the ground rail. Similarly, yellow pin Arduino D3, it is connected with the resistor, then lead anode, lead cathode, and then the ground rail. Then green lead pin 5, Arduino D5, resistor, lead anode, lead cathode, ground rail. Then comes the buzzer, of course, and then it is either it is connected to D9, and then buzzer is first positive, and the positive part is connected to D9, and then the negative part is connected to the ground. So this is how we are connecting all the different resistances, and you can see the same in the same line we are connecting the leads, right? So that means from resistor we are connecting the lead directly, and then we are connecting it to the ground line, and or it could be ground line or any one of the lines where it is directly connected. And so that once it is connected, we can now connect the different pins to the different pins of the microcontroller as per the different resistances as given over here. We are connecting from Arduino D2 or resistor to Arduino D2 or D3 or D5 as per the requirement, and this is the jumper wire, so we can connect very easily, and once it is done, automatically our circuit starts. So and we can also monitor that in the serial monitor as well. So once the connections are all done, as you can see that this is the ground pin is getting connected, I guess. Yeah. And now we are ready. The microcontroller is now ready to execute the program. So now we are compiling the program, and once the program gets compiled, then it is saying done compiling, and that means then we have to upload the program. And once we upload the program, then obviously the program will start running continuously in a loop inside the microcontroller. So compilation is happening, and then once it is compiled, then we can upload it, and once it is uploaded, then automatically it starts, right? And we can see the serial serial monitor over here. Whatever is happening in serial monitor, I have added that over here, and you can see as we are blinking, or which one is blinking, red or green, we are also typing it out, and then you can see what is happening, in what sequence it is happening. Now this actually helps us to confirm that whatever commands we are giving is executed or not, so that we can check in the serial monitor, and then automatically if there is a mistake, we can correct it. So you see it is also making some amount of sound as well. So if I am pressing on this switch, automatically the system is stopped. So in between I pressed, and you can see the system got stopped, and then when I released it, it again starts. So these are some of the references you can use. And to conclude, Arduino based prototyping integrates software programming, hardware interfacing and breadboard circuit design to enable real-time sensing, control and actuation in embedded and IoT systems. Thank you.